Welcome to Getting a Grip on Logs, Part 1. However,
you cannot learn about logs until you understand exponents.
Come again?
You cannot learn about logs until you understand exponents. You have to know the rule of exponents.
Exponents, indices, powers, they all mean the same thing. Repeated multiplication of a base. So here you see 2 to the power of 4 is 2 times 2 times 2 times 2. You have a base and you have an exponent. But here is a very important announcement.
You have to know these and you also have to understand them.
The thing is, you won't get the exponent laws in your formula booklet. You need to understand how to work with exponents in the same way you understand how to do multiplication and division. But you do get the log laws written out for you to help you. So here's those exponent rules again. But there's only one way to get really good at understanding and using them.
Practice, practice, practice.
Let's get one of my friends here to help us out.
Pick me, pick me.
Okay, you get the job. So here we have B for the base.
Ow.
And here is P up the top for the power.
Ow.
And the answer is N for a number.
Ow.
What's up?
Mate, these pins hurt.
Shut it. Okay, so let's go pick a number.
2.
No, that's too easy. Let's go big, really big.
Okay, 3.
Very funny. 3 it is. Here we go. So now we have 3 as the base, 4 as the power, and we need to find N.
Mate, easy. 3 times 4 is 12.
No. You have to take your base 3 here and multiply it by itself 4 times, okay? And 3 times 3 is 9.
Dude, that's cool.
Well, hang on, it gets bigger. We triple that, and then so we got 9 times 3.
Dude, huge. 9 times 3 is 27.
Yeah, but we're not finished.
Okay, mate.
So now we multiply that by 3 again.
Mate, that's a lot.
Yep, it's a lot. So if you count that up, we get 3 to the power 4 is equal to 81.
Mate.
What?
You keep sticking pins in me.
Shut it.
What's all this got to do with logs? I thought this video was about logs.
Hang on, I'm getting to that.
So, logs.
Not that sort of log.
Hey, that's not a log anyway.
Yeah, I know.
It's a tree stump. Dopey dude.
Back to the B, P, and the N. We know that the base to the power of P is equal to N, but did you know that P is the log of N?
Get away.
Okay, so let's move things around and see how this looks. So, hang on, that B's too big. It's got to be small.
Why?
Well, it's convention. Plus, you don't want to confuse things. You need to show clearly which one is the base. So, hang on. Okay, so that's better. So basically, the log equation is just saying how many times do I multiply this base to get this number. So log base 3 of 81 is equal to 4.
Well, how long do I have to do the splits like this?
Shut it.
So watch how I change this logarithmic function back to an exponential function, and then the exponential function back to a logarithmic function. And without the silly reindeer,
Hey.
here's what it's going to look like. And using our previous example, 3 to the power of 4 is 81, and log base 3 of 81 is equal to 4.
Hey, that guy thinks he's on a log too. Ha ha ha.
So in order to check that you understood all of these, I want you to solve these logarithmic equations and change them into their exponential form. So go ahead and pause this video and try them out. So how did you do? Did you get the same answers as me, such as 7 to the power of 2 is 49 and 3 to the power of 5 is 248? And did you remember that 2 to the power of 3 is 8, but you need the inverse, so 2 to the power of negative 3 will give you 1 over 8. And the same applies for the next example. And did you remember that the log of 1 is always 0, because anything to the power of 0 is 1, except of course 1 could be 1 to the power of 1. How did you do on these ones? Hopefully you did really well and are ready to move on to the next phase, where I'm going to ask you to do the opposite. Change the following exponential expressions into their equivalent logarithmic form. So once again, go ahead and pause the video. So how did you do? Well, log of 10,000 base 10 is going to be 4. Just count the zeros. But you know, you don't really need that 10 there. You can just rub that out, because the word log without a base implies base 10. Now I'm sure you got all of these correct as well. Now here's two really cool properties of logs. You can't have a log of a negative number because there's no exponent of any number that's going to give you a negative value, so it's totally undefined. In the same way, log of 0 is undefined, because what possible exponent of any number is going to give you 0?
Another important property of logs is that log base b of b to the power of x is equal to, well, let's have a look at that. If we were converting that to exponents, we're saying what power of b will give us b to the power of x, and it has to be x. So let's have a look at that with another example. What is log 3 of 3 squared? What is that equal to? Well, it's asking us what power of 3 will give us 3 squared, and it has to be 2. So again, let's do another one. Log x of x to the power 3 is going to be equal to 3. You might see this, and this is equal to 4, because what this is telling me is the natural log. So say the log of e, but we write it using ln. So that question is just the same as what power of e will give us e to the 4th, and of course it's the same. An important log rule is the product rule, and this is how you will see it written in your formula book. But let's switch this around. Now, does this remind you of something? Do you remember the exponent rule? A to the power of m times a to the power of n is equal to a to the power of m plus n. And this is how you relate these two. But let's look at an example to make it clearer. Let's go back to our original example where we have log base 3 of 81 is equal to 4. And we said that the exponent version of that logarithmic equation is 3 to the power of 4 is equal to 81. Now let's break 81 down into 27 times 3. So writing that as a log, I've got log base 3 of 27 times 3. Now that is equal to log base 3 of 27 plus log base 3 of 3. We know that this is equal to 4. Log base 3 of 81, because this is 81, is equal to 4. Now, what power of 3 gives us 27? Well, that's just 3. 3 to the power of 3 is equal to 27. And what power of 3 gives us 3? Well, that's just 1. 3 to the power of 1 is equal to 3. So then we can see that this is 4 is equal to 3 plus 1. And that's why we add the logs when we're looking at a log law like that. So going back to how it was written before, so we say we have log of m times n, we can split that into the log of m plus log of n. As long as your bases, of course, have to be the same. You can't add up exponents if the base is not the same. So you can't do that with logs. You have to use the same base. And this can be very useful for breaking up logs. Say you need to rewrite log base 2 of 8a. Well, that's going to be log base 2 of 8 plus log base 2 of a. Now, can we simplify this? Yes, we can, because 2 to the power of 3 is equal to 8. So this is 3 plus log base 2 of a. So you might be able to use that rule when you're trying to manipulate logs. For the quotient rule, and quotient just means the answer from division, you will see in your formula book the rule is written like this. Now let's switch that around. So this relates to your exponent rule where you have a to the power of m over a to the power of n
is equal to a to the m minus n. Now remember again, this is only working if you've got the same base. Let's look at log to the base 2 of x over 2. Now that's going to equal log to the base 2 of x minus log to the base 2 of 2. But I can simplify that further, because what power of 2 will give me 2? And that has to be 1. So this is equal to log 2 of x minus 1. And that's the same thing. So let's look quickly at our favorite number, 81. That's going to be equal to log 3 81 minus log base 3 of a. Now we all know what this is equal to. We know that this is equal to 4. So the answer is going to be 4 minus log 3 of a. The log of a power is shown like this in your formula book. Log base c of a to the r is equal to r times log base c of a. And that relates to the power rule, where you have a to the power of m all to the power of n is equal to a to the m times n. And that's how you relate the two. Again, let's look at our favorite example. 3 to the power of 4 is equal to 81. Well, that's just the same as 3 to the power of 2 times 3 to the power of 2 is equal to 81. So that's 9 times 9 is equal to 81. So let's say 9 squared is equal to 81. So how about we just practice this rule using that information? So let's look at log base 3 of 9 squared. And that, by this rule, is going to be 2 times log base 3 of 9, which is 2, and we know that log base 3 of 9 has to be 2, which is equal to 4, and that gives us the correct answer using the log of a power, this one here. So that was written, remember, as log base 3 of 81 is equal to 4. Now that just shows you the log of a power in an action. Now the secret is that you might need to combine different log laws together to solve more complex problems.
Finally, someone who knows what a log is.
So here's a really useful rule. Change of base rule is shown in your formula booklet just like this, and it's very useful for if you're working in different bases and you need to put them all in the same base. And if you look carefully at the way it is, I've got base B, but I want to work in base C. So I take this number and do the log of the new base of A, and then I find the log of the new base of the old base, B. So look very careful how that worked. B went to the log of the new base there, and that went to the log of the new base at the top. So how might this be useful? Well, you know, on your calculator, you've got the option of this log here, which is base 10, and this one, the natural log, which is base E. So how might you use that if you're in a different base? Let's have a look at an example. Let's move the calculator down over here. And remember, you've got your button here for natural log and log here. So let's look at it. Say you're trying to evaluate log base 3 of 6. Well, I need to change that. So let's change it into log base 10. So log of this original, remember we take this one first, log of 6 over, and now we have to find the log of the old base, so that would be log of 3. Now I can put that into my calculator and I'll come up with 1.630 . Now I could have chosen the natural log. I could have said log base 3 of 6 and used the natural log base E. Okay, like that. And of course I can calculate that on my calculator and it'll give me the same answer. Or there's a 9 there, so if I wanted to put this to 3 decimal places, it would be like that. Or 3 significant figures, it'll just be that. Okay, and that's how it's useful, because of course you don't have other bases available to you here, but you do have the natural log, which is base E, and you have the other log base 10. So that's how the change of base rule could be very useful. So now you're ready for part 2, which features lots more exciting pictures of people on logs, and where you get to put all this knowledge of log rules into practice. Oh no, this won't end well.
Thanks for watching.